Very good morning, students. This is Kar Kurli, Assistant Professor, Triple Department from RMD Engineering College.
Today we are going to discuss about inductance of a single phase two wire line. In single phase we are having two conductors, one is phase and another one is neutral. Here we are considering a conductor A and conductor B. Both are having same radius R and they are separated with the distance of D, and they carry equal current but in opposite direction. So we can write the current equation as IA is equal to their magnitudes are same, but they are opposite directions. So we can write IA is equal to minus IB like this. Now we are going to find out inductance of a single conductor. Then the loop inductance will be twice of this single conductor. Correct. So first we will discuss about inductance of a single conductor A. For this conductor, the flux due to its own current, that is IA. So we have to find out flux linkage due to its own current. So first thing. Second one, first thing due to its own current IA. Another one, the flux linkage will be there due to the nearby conductor current, which is IB. So the flux linkage due to IB. These two things we have to find out. Okay. So then we know the inductance is flux linkage per current, psi by I. Correct. This is what our aim to find out. Okay. Now for this first, I already told IA equal to minus IB. If you make it as an equation, we will get IA plus IB equal to 0. Now due to flux linkage due to its own current, we have considered the conductor A, no? So conductor is having its own current IA. So for a single conductor there are two flux linkages. One is internal flux linkage, another one external flux linkage. So the equation for this is mu naught IA by 2 pi 1 by 4 plus integral of infinity to or dx by x. So this is due to its own current. Then the flux linkage with the same conductor A due to current IB. IB is the nearby current, correct? So the same thing, flux linkage mu naught IB divided by 2 pi, this 1 by 4 will not be available here. Then integral of d to infinity dx by x, this d is nothing but distance between two conductors is considered here. Now total flux linkage with the conductor A is due to its own current, which is nothing but expression 1, and due to current IB, that is expression 2. We are adding these two, so we will get this one. And here we are substituting the upper limit and lower limit. 1 by 4 mu naught divided by 2 pi, we have taken 1 by 4 as it is. Then for this integral term we are substituting the upper limit and lower limit. We know integral of dx is equal to log base e infinity. The same thing can be written as ln infinity, correct? Instead of log base e we can do ln infinity also. Okay. So log base e infinity, this is upper limit, minus lower limit ln r. Hereafter I will call, instead of log base e, I will call this as ln, okay, instead of log base e. Then for this term mu naught IB by 2 pi, and substituting the upper limit and lower limit here, ln infinity minus ln d. Then rearranging these things together, and see here ln infinity here, in this term also ln infinity, taking commonly ln infinity here, and we will get IA plus IB. We know already IA plus IB is equal to 0. So this term gets cancelled here, correct? The remaining terms are IA divided by 1 by 4, taking IA inside, and 1 by 4 minus IA ln R minus IB ln D. So what I am doing here, just I am doing the substitution here. I know IA plus IB is equal to 0, or IB can be substituted as minus IA, correct? Now I am replacing this IB or this one, correct, in this equation here. IB is equal to minus IA, so minus of minus IA will become plus. So the minus IB is replaced by plus IA, correct? There is a small change. From this equation to this equation we are having a small change. Okay. Now see here, in all the term IA is common, so I can take IA as common here, and then we know already ln A plus means plus. These things are very basic things, so unless otherwise we are aware of these things, it is not possible to understand here, correct? If natural logarithm terms are an additive, no, the equivalent value, no, ln the values can be multiplied. So A multiplied B, A multiplied by B, ln AB, we can write like this, correct? Suppose the same thing, no, instead of plus, so if you get this as minus, okay, this as minus, ln A minus B. So what we can do, no, divided by, see here, divided by B. So ln A by B. I'll do it again so that you will understand. Ln A divided by B. Okay. So the same concept only here used. I is taken as common. See here, ln R minus ln R plus ln D. So D will be in numerator and R will be in denominator. Ln of D by R. And in this term IA is common, so taken IA is common, and then the left out terms are 1 by 4 plus ln of D by R. Then inductance of a conductor, I told you what is the formula for that. Flux linkage inductance is equal to flux. This is very basic one, correct? Basic equation, flux linkage per current. So if it is for conductor A means psi total flux linkage divided by IA. We know the total flux linkage. What is the total flux linkage? Linkage, flux linkage due to its own current as well as flux linkage due to its the neighbor conductor current. Here is IB, correct? So flux linkage due to IA and IB together, this is the overall flux linkage, then divided by IA, correct? If you substitute IA, this is actually IA. If you substitute IA, the numerator IA will get cancelled, so we will get this term. So now this is the inductance of a single conductor. But in single phase, I told you we are having two conductors which carry the same current. So loop inductance, they will ask you loop inductance. Loop inductance is nothing but now twice that of the inductance of a single conductor. And we know the next thing, no, we know mu naught can be replaced by 4 pi multiplied by 10 power minus 7 divided by 2 pi. So here 2 pi and this 4 pi gets cancelled, we will get 2 into 10 power minus 7. If you take 2 inside, so we will get 1 by 2 and 2 gets multiplied here, 2 ln of D by R. So LA is equal to 10 to the power minus 7, 1 by 2 plus 2 ln of D by R. So I already told loop inductance is equal to 2 LA. So we will get, again 2 is to be multiplied in the above equation inside. So what you get, 1 plus 4 ln of D by R. Okay. The same equation can also be written in the another form. How about another form? No. See here, LA we know inductance of a single conductor 10 to the power minus 7, 1 by 2 plus 2 ln of D by R, correct? If I take 2 into 10 power minus 7 means that is taking 2 outside, you will get 1 by 4 plus ln of D by R. Now this 1 by 4 is to be combined as a single term, that is these two terms are to be combined in single term. So this is to be combined here. This is a constant, 1 by 4 is a constant. How it can be written? Ln of, correct, ln of e power 1 by 4. So if you take anti-logarithm for the ln, no, natural logarithm, you will get e. So like it is similar to no a in a inverse. What happened? A inverse both gets cancelled, correct? A inverse and a gets cancelled. Same manner ln and e gets cancelled, so you will get 1 by 4 only. So now the concept is 1 by 4 now can be written as ln e to the power of 1 by 4, correct? Now see, both are in ln operation. I told you log to the base e. This one I will tell it as a ln only hereafter, correct? So here also ln term, both are in ln term, but they are additive. They can be combined, correct? How they can be combined? Ln of, like this we can combine, both can be multiplied. So how it can be multiplied? Ln of e power 1 by 4, then multiplied by additive, no? So we can multiply d divided by r, correct? Then e power 1 by 4 can be taken into the denominator. How it can be taken? E power minus 1 by 4. See here, r e power minus 1 by 4. Now you know the r e power minus 1 by 4 is considered as r dash. R dash. E power minus 1 by 4 value is, if you use your calculator, you will get this as 0.07788, correct? So now r dash is equal to this value multiplied by r. This r dash, no, we call this as self GMR, geometric mean radius. Okay, this is very important term in the case of inductive effect of a inductance effect in a conductor. Okay, this is very important. This r dash is equal to, I already told, 0.7788 r is applicable only to the solid conductor. Please remember that one. Okay, so this is the final formula. LA is equal to 2 into 10 power minus 7 ln of d by r dash. Okay, this is inductance of a single conductor. For loop you will get twice, 2 into 2. So 4 into 10 power minus 7 ln of d by r dash. Okay, thank you all for watching this.